So let's have a look at the square root function. For example, let's start with the basic one, y is equal to the square root of x. This is the shape that we're looking at. Square root is always defined as being positive. So if we were to graph it, it looks something like this. So you go to whatever value across the x-axis, like 4 on the x-axis, plug it in, returns a value of 2 on the y-axis. Or if I go to 9 on the x-axis, it returns a value of 3 on the y-axis. So that's the general shape there of the square root function. Now a, h and k obviously will shift it around. No surprises for guessing that k moves the graph up and down the y-axis. The h in here shifts the graph left and right. So everything is exactly the same as all the other functions. K shifts it up and down, h shifts it left and right. A, no surprises once again for guessing, that's our dilation factor. As a gets bigger than 1, it makes the curve dilates closer to the y-axis. A less than 1, further away. And if I made a negative, just like with a quadratic, it'll flip the curve over to be like that. So a, h and k have all the same effects that we've been used to so far. We can change this around a little bit. So instead of having the curve shooting off to the right, if I were to change it so that I had the square root, instead of x minus h, I did h minus x, that has the effect. Instead of flipping it in the x-axis like a does, all my x values have now been negated, they've been switched around. So this one would point off that direction. So there's the transitions that you need to know about. A will dilate it, h will shift it left and right, k up and down, and then if we switch this around to be this, it switch the curve around to be like that. Okay, let's have a look at this particular graph here. Let's talk about the 3 prime numerals and what they do, and we'll graph it. Now, we know we have an a value of -2, so it's going to flip the curve upside down, and it's going to dilate it, make it go closer to the y-axis. We know we have an h value of +3, so it's going to be shifted 3 places to the right, and a k value of +1, so it gets shifted up 1 place. So let's have a look at what that's going to be like when we come to graph it. So first of all, it would normally start at the origin, but this one's going to start 3 places over and 1 place up. So the curve's going to start there. Now instead of normally travelling upwards like that, like the normal square root will be, because we have an a value of -2, it's going to be shaped like this. So clearly we have an x-intercept, which we can easily work out. First of all, let's write this coordinates at this point in. It's been moved over 3, up 1. So the curve starts here. None of these values here exist. It's like if I put x equals 2 into here, I'd have 2 take 3, which is -1. Square root of -1 doesn't exist. That's why the curve starts right there and nowhere else. Now, let's go through and work out where it's going to cut the x-axis. Of course, that happens when y equals 0. You might have to pause the video now, have a go, substitute x equals 0 in, substitute y equals 0 in, and see if you can come up with where it cuts the x-axis. Have a pause, see if we come up to the same answer. So I think that it's going to cut the y-axis, cut the x-axis at 3 3/4. 3 1/4. So there's the x-intercept. And that's really all there is to the square root function. So you can practice them in class and see how you go. So best of luck with that.